Assalamualaikum and good morning. My name is Wan Muhammad Fudai bin Wan Makhir. My trade number B0717103635 from 4BMMA section 1/2. Today I want to present my PSM2. The title is Design and Fabrication of an Adjustable Wheel Nut Remover and Tighter by using Universal Socket. The introduction of my project is the demand for adjustable multi-nut remover and tighter in large quantity is on the increase due to its ability to remove or tighten 4-wheel nut from a car tire at a time with less application of force. Due to the difficulty of applying the necessary torque to loosen the nut, driver most of the time rely on the tow truck and nearest mechanic available to solve the problem. The problem statement in this project is, in order to solve the difficulty and inconvenience for the user when removing or tightening the wheel nut of the tire, a tool that can remove all the 4 nuts in single stroke at the one time is designed. Common tool tire replacement cost time consuming and need a lot of human effort for fixing all 4 wheel nuts. So in this situation where time is valuable, this common method become really inconvenient. Objective of this project is to design an adjustable wheel nut remover and tighter. This can be accomplished by applying many mechanical principles. To analyze the gear design of an adjustable wheel nut remover and tighter by using ANSYS Workbench software. Then to fabricate an adjustable wheel nut remover and tighter with universal socket. For scope of study, this device is specifically designed for automobile using 4-wheel nut in a single tire. It was a quick and easy way to replace tire. In addition, this setup is even more ideal for using tire replacement in a car to minimize the time spent and to reduce the effort expended by the man for removing the tire and to resolve emergency situation. This tool uses a universal socket wrench that can remove the size of nut from 11 to 32 mm. The pitch circle diameter (PCD) is 4 × 100. Working principle of this tool is, this tool consists of 5 gears, shaft, universal socket and ball bearing. First, this tool must be set up in the perfectly fitting of the universal socket to the wheel nut of the vehicle. Then, the main shaft must be connected to air gun, lug wrench, T-wrench or torque wrench rotated the gear in this tool. The rotation of the shaft which then lead the universal socket at the end of the shaft. As the shaft rotates, the universal socket also turns and the nut in the wheel thus removed or tightened by the rotation of the socket. The tightening and removing process can be changed by changing the rotation of the motor. Thus, the wheel nut can be tightened and removed by this process. For literature review, this is the existing product of wheel nut remover. First, the existing all-wheel nut remover conceptual design by Abdul Aziz from 2008. Then 5-in-1 nut remover conceptual design from Amol Banesh 2015. Then product assembly Amol Banesh 2015. Component that used for this tool is first gear, bearing, base plate, shaft and universal socket. Methodology. For final year project 1, first thing is project planning. Second, literature review. Third, function establishment. And lastly is task specification. For final year project 2, first is conceptual design and development. Second, detail design. Third, discussion. Next, conclusion and suggestion, and lastly, presentation. Then we go to the material selection of adjustable window remover flowchart. First is start, mechanical method, general material requirement for an adjustable window remover, then initial material selection, cost per unit strength method, digital model for adjustable window remover, force calculation, if yes, meet the requirement and select material, if no, new material selection, and then force calculation again, if meet the requirement, select material, then end. Next is fabrication process flowchart. Figure 3 show that fabrication requirement to develop machine in this project. First, start material inspection process, material preparation process. If yes, follow the design. If no, material preparation process again. Then measurement and marking process, cutting process of all part needed, grinding process to remove burr and sharp edge, drilling and punching hole, dimension inspection, assembly and welding process, position alignment, and end. The next one is gear design calculation. This is an example of gear design calculation. We can see from this part. Next is assembly of adjustable window remover and tighter operating tool component. This figure show the model of Martina operating tool assemble. Then next is explode view of the model. We can see through this figure 2 and 3. Next is result and discussion. This is result and analysis of an adjustable window remover and tighter in the form of stress variation pictures. The outcome of the analysis are created. The red colored area indicates the strongly stressed or deformed region in a component, and the corresponding value are shown according to the color variance scale. The finding of the static structural analysis using ANSYS workbench are seen in figure 5 to 12. The boundary conditions that are applied to the model are seen in figure 6. You can see figure 6 in the right one. The fit condition of the bearing is given, and the central shaft is given a torque of 120 Nm. The maximum equal Von stress value is 419.26 MPa, seen in figure 7. Figure 8 reveals that 0.0021 mm is the highest corresponding elastic strain value. Figure 9 reveals that the overall natural stress value is 186 MPa. The maximum value of the standard elastic x-axis strain is 0.00047 mm, as seen in figure 10. Figure 11 and 12 indicate that 4.759 MPa and 0.000451 mm respectively are the highest value of shear pressure and shear strain. The findings are tabulated in table 1.0. Next is end product. After all part is done, it's ready to assemble. This required high skilled person to produce the product became precisely and in the correct angle before it can be used and manufactured. The duct and chimney were separately insulated sealing crucial gap formed due to imperfect welding. The hole at the casing plate that will hold the shaft not in correct angle because lack of skill while drilling the hole, that caused some bend when the shaft is installed. This figure show the complete of adjustable wheel nut remover and tighter by using universal socket. For conclusion, an adjustable car tire wheel nut remover or tighter with 114.3 PCD has been made. The specification of the flexible wheel nut remover and tighter has been completed and performed appraisally has been successfully performed. It clearly indicates from the finding obtained during the performance assessment that the system can detach and tighten the four wheel nut of the car tire easily with little application of force and time expended. However, in order to further minimize the weight of the unit, a comprehensive feasibility review is recommended to locate possible materials that are lighter in weight. Then, for limitation, due to COVID-19 impact that affect the entire world, it is hard to find the correct material and equipment that should be used to complete the fabrication process, same as the design. So the material selection should be easy to get and has a good quality. Professional skill in manufacture and welding needed to make a perfect tool in every aspect to ensure no loss of energy required to the tool when remove the wheel nut from the vehicle tire. Lastly, for future scope, to get a perfect size of gear that needed to fabricate the mechanism, need to think another method to use something that easy to get, for example sprocket. Height skill required to fabricate this tool to ensure the diameter angle of the PCD in correct and precise position, same as in design. The tool will function perfectly if all the precision is correct. That's all from me. Thank you.